Okay, today we're looking at Grade 5 Module 2, Lesson 6. Connect area models and the distributive property to partial products of the standard algorithm with renaming. And this is kind of a continuation of Lesson 5. So our first problem, we have 73 times 64. We're first going to set it up in an area model. And we're going to break apart both numbers this time instead of just one. So we're going to have 60 times 4, and then 70 plus 3, I should say, 60 plus 4. And we're going to treat each of them as a partial product in this case, thanks to the distributive property. So we're going to have 4 times 3 ones equals 12. 4 times 7 tens equals 280. 6 tens times 3 ones equals 18 tens, or 180. And then 6 tens times 7 tens equals 42 hundredths, or 4,200. And now let's go ahead and make that connection to the standard algorithm. So again, we have 4 times 3 ones equals 12 ones. So we're going to go ahead, put down our 2, and regroup our 110. Then we have 4 times 7 tens, that equals 28 tens, plus the one we've regrouped gives us 29 tens, or 290. Continuing, we have 6 tens times 3 ones equals 18 tens. So we're going to go ahead and put down our 8 tens and regroup our 110. And then we have 6 tens times 7 tens equals 42 hundredths, plus the one we regrouped gives us 43 hundredths. Add them up, we have 2. 9 plus 8 is 17. We're going to regroup 1, put down the 7. 3 plus 2 is 6, plus our regrouped 1. 3 plus 2 is 5, plus the one we regrouped gives us 6, and then 4. 280 plus 12 equals 292. And 4,200 plus 180 equals 4,380, giving us, again, the connection between the area model and the standard algorithm. This time let's look at a 3-digit by 2-digit number. So it's a little more complex, but again, the same strategies will apply to a 3-digit number. Now we're looking at 39 units of 814. So we're going to break up by place value, 800, 10, 4, 8, 10, 4, 39. Always try to keep the smaller digit on top here. As we can see, it will line up with our standard algorithm. So, first 9 times 4 ones, 36 ones. 9 times 110, 9 tens, or 90. 9 times 8 hundredths, 72 hundredths. 30 times 4 ones, or 3 tens, times 4 ones gives us 12 tens, or 120. 3 tens times 110 gives us, 3 tens times 110 gives us 3 hundredths, or 300. And then 3 tens times 8 hundredths gives us 24 thousandths. And here we have 24 thousandths. Add them up, we have 7,326, 24,420, 3,100, 31,746. Now making the connection again to the standard algorithm, 9 times 4 ones gives us 36 ones. 9 times 1, 10, equals 9 tens, plus the 3 tens we regrouped gives us 12 tens. So we're going to put down our 2 tens, regroup our 10 tens, or 100. 9 times 8 hundredths gives us 72 hundredths, plus our 1 extra hundred that we regrouped gives us 73 hundredths. Now let's look at our 3 tens. So then our 30, here's our 30, or 3 tens. 3 tens times 4 equals 12 tens. We're going to regroup our 1 and our 110, put down our 10 tens, and put down our 2 tens. 3 tens times 110 equals 3 tens, plus our 110 equals 4 tens, or 4 hundredths, I apologize. 3 tens times 1 10 equals 4 hundredths. And then 3 tens times 8 hundredths equals 24 thousandths. And so we have 24 thousandths. Add them up, and again, we have the same connection.